welcome back to the third video of Master IV Fluid course. And today we're going to continue on the second questions, what kind of IV fluid? And just to refresh your memory from last video, we talked about two important principles that we said: the higher tonicity of a solution, we said that means less free water and higher tendency to stay extracellularly, and mainly extracellular we said interstitial, and intravascular we mainly talk about intravascularly. So this kind of solution with higher tonicity are really excellent and should be picked for volume resuscitation. This is just to refresh your memory, okay? Now today we're going to talk about these solutions, and I want to demonstrate to you that all these crystalloid solutions made of water, and I'll show you how easy to know how they make these crystalloid solutions. That's why they are way cheaper than the colloid solution. And all our discussion so far been, and it will be, on crystalloid solution. So just pay attention to that. Okay. Let's start with this container. I'm gonna draw this container. Let me change the color. Let me just put a red container. Okay. And we're gonna fill this container with water. 1 liter of water. So this is 1 liter of free water. Okay. Now, I decided to add on our first case, I decided to add to this 1 liter of water. I wanted to add 154 milli equivalent of sodium and 154 milli equivalent of chloride. And the way they do it, actually they put 9 grams of sodium chloride into this. So 9 grams of sodium chloride, you just put it on this 1 liter of free water. That will give you the 0.9%, right, NaCl solution. And this will give you this concentration of sodium and chloride. So simply by adding this to 1 liter of fluid, I made a liter of normal saline solution. Okay, so the osmolarity of this solution basically is 154 multiplied by 2, and this equals 308. Remember, this is close to the 290 of body osmolarity. That means tonicity is pretty close to the body, and that means this is isotonic. So it's on the higher tonicity side, right? This means that this water is full of these sodium chloride molecules. So free water in this solution almost equal to 0 or minimal, just to be more accurate. So the tonicity is on the high side, equal to the body tonicity. Free water is minimal. And that's very important to understand, that when we come to what solution we need to pick for what indication. So remember that. It has no potassium by itself. Okay? But imagine we decide to add potassium to it, 40 milliequivalent. What's going to change? What's going to change is this equation, because now the 308, you need to add 40 to it, because potassium is what is an osmotically active agent. So 40 plus 308, this is 348, and this is bigger. So now this solution became hypertonic solution, has higher tonicity and has less free water compared just to normal saline itself. If you add 80 milliequivalent of potassium, it's a higher tonicity solution. So you just add these milliequivalents and compare them to the 290, and that's how you decide this is isotonic, equal around 290, hypertonic way above the 290, and hypotonic way less than 290. And also this solution, the normal saline solution, the NaCl, has what we call no buffer. That means it has nothing that will counteract the acidosis. And that's why there's no bicarb, there's no lactate. That's why one of the problem of normal saline that can cause normal anion gap metabolic acidosis. And usually this we call hyperchloremic metabolic acidosis, because the chloride go up. Regardless of the exact theory behind that, is just remember that there is no buffer. It has nothing to counteract acidosis. That's why it causes, or that's why it's associated with normal hyperchloremic, normal anion gap hyperchloremic metabolic acidosis. This may not be completely accurate, but easy to memorize. Okay, and the practical word doesn't matter. Also, because this has minimal or no free water, when you give normal saline, you may induce hypernatremia. We'll come to the hypernatremia and show you how easy this topic to understand, hyponatremia and hypernatremia. But sodium and free water goes hand in hand. Less free water, higher sodium. More free water, lower sodium. So I want you to understand that. So I'm going to stop here. I don't want to make the video too long. But this is how we made normal saline from a liter of water. So see, the essence of all crystalloid solutions is free water, and depends what you add to it, you decide what kind of solutions. Next video, I'll show you the other solution, how we make them. The lactated ringer, half an S, quarter normal saline, D5W, T10W, and all of this. So stay tuned. Thank you. Thanks for watching this video. Please subscribe to our channel and activate the notification bell so you get to see the videos as soon as they are released. Glad to have you on board.